good afternoon, everyone, or good morning or good evening, depending on where you are, and especially for the members that are attending the event remotely. I really look at the demo from Rex. I think it was a great presentation. I noticed that you had a family member called Brandy, a dog, and in the light of the community that I think we are starting and establishing, we can definitely help there, because we'll show you something that will help our pet friends. Starting our real presentation, my name is Filipe Prezado. I'm a program manager within the Azure Mobility product group. Together with me, I have Atif. Atif, so do you want to just...
Yes, hello. So I'm one of the software engineers who's been contributing to some of the demo that you will be seeing later on in support of the concepts that Filipe will be presenting. So if you have any questions about that, I'm afraid I had come over here to give you a live demo of that, but it seems like that the best approach would be to do the video playback that we had as a backup. But if there's anything unclear, I have my laptop here with everything set up. The demo gods are not here with me today, so I'll be able to show it to you later on. Thank you.
Yeah, and I also would like to call out that we have several members of the Microsoft group in the audience. So during the break or also during the event, especially we have Sean Salitrenikov, which is our dev manager from the Azure Mobility group. And also there was multiple contributors to this first code contribution, which I would like also to call out. You'll see several members at the end of the presentation, but mainly Boris Scholl, who was planned to be here with us as well. So with this, can we, and I don't know if this works. Oh, yeah, it works. So when we were looking at our first contribution to the community, First, we came up with a very interesting project named Chariott, which is not definitely a mistake when we were reading and submitting with the two T's. But we aim to simplify and enhance the in-vehicle developer experience. And you'll see during the demo that experience and how that experience is achieved by the multiple layers of the architecture that we are proposing through this Eclipse Chariott. You also see that the digital representation of the vehicle through their states and capabilities is one of the key components that we are, again, making available to the audience, making available to the community so that we can jointly move on and improve the software-defined vehicle implementations. So when we were looking how to, and now Rex, now you understand. So when we were looking how to best demonstrate the key capabilities and the key concepts of the architecture, we thought that it would be great to create an application for one of our in-vehicles simulations. We created a dog mode, and you'll see during the demo that basically we want to make sure that our pet friend is safe and healthy if we need to leave the car. And we do this by, driving with a dog. I own a dog with me, and he travels with me. He's always making sure that he gets my attention. But when I need to leave the car, I want to make sure that the dog is definitely safe. So you'll show, or you will see Atif during the code walkthrough doing and turning on the dog mode on. You'll see that the temperature is going to start to increase as we park the vehicle and we need to get outside. And by getting events from the underlying and providers that the vehicle exposes to the developer, it can react on that temperature threshold and automatically set the air conditioner on and notify the user that, okay, now your dog is safe, now your pet is in a healthy state. So with this, moving on, what you'll see from our demo is the initial of the architecture. And we came up with, for this presentation, something that can easily be taken, although we are already working through the future architecture that we'd like to start discussing with the community here. So at the bottom layer, vehicle integration providers, they will expose, or we would like to see them expose it through in a dynamic way and metadata driven. We'll see an application programming model that is essentially composed of two big components at the moment, with an in-vehicle digital twin, which exposes the state and the capability capabilities of the underlying providers, but also provide a registry so that the applications can register themselves and can be notified, can get the set or gets from the underlying events. And on top of that, the in-vehicle applications that will consume the middleware and the application programming model in a very agile and productivity way for the developers itself. So in terms of key concepts, we would like to show to you, and you'll see highlighted during the demo, is that it's an extensible and dynamic architecture. It provides metadata to the in-vehicle digital twin, and it provides that hardware abstraction through the in-vehicle so that the applications can consume. Especially during the code demo, you'll see a dog mode provider being used. In the middle, the two key components that I've just mentioned, the application programming model through their capabilities to do dynamic registration of the applications, but also the discovery of those existing applications and capabilities, an event subsystem, and then, of course, the necessary messaging that is needed for the applications to talk through. And last but not the least, in terms of the in-vehicle digital twin, the metadata-driven, those capabilities abstracted from the underlying sensors and hardware that the vehicle is exposing to us. With this, what we are looking for and what we would like to drive the community is definitely the developer productivity, the velocity, make sure that we can develop in the cloud, deliver in the vehicle, and make also agree with the community that is language independence or also toolchain independence. And for this, you'll see us doing a demo with Rust, but also some of the code for the application written in C#. We have examples written in Python, and of course we have also C++ implementations that, again, with the community would like to work and understand what are the set of languages that would make sense to take the software-defined vehicle moving forward. And with this, I would like to have Atif now doing the code demo, which is of course not possible. So if you could place the video.
So we've been experimenting with an incarnation of the application programming model by implementing it in code and exercising an architecture for the various concepts mentioned earlier. We wanted to explore the experience the application programming model could deliver for developers as well as integration providers. But before digging into the actual code base to connect you to the implementation, we're going to start by looking at the dog mode scenario in action, seeing the execution flow all the way from the provider simulating the dog mode scenario to the runtime, and finally an application running the business logic. Here you see 4 panes. The bottom left is where you will see the runtime running, which houses the digital twin store and the provider registry. You can imagine the SDV runtime as a dynamic broker between applications and providers based on the capabilities needed and offered. The bottom right pane is where a mock provider will be simulating sensor data to support the dog mode scenario. We'll see the provider register with the runtime, announcing its capabilities, data, and functions, and then publishing data such as the cabin temperature. It will also respond to any function invocations such as setting the air conditioning system on. Finally, we have 2 applications in the top 2 panes, one that is displaying the dog mode UI on the right, which we'll imagine is appearing on some panel on a car's dashboard. The other on the left will execute the pure dog mode logic based on the simulated conditions in the mock provider. Both applications will be subscribing to events to monitor data like the cabin temperature. We'll see the dog mode logic application on the left turn on the air conditioning system on if the temperature passes a certain threshold, and also notify the user that the dog is safe. So I'm going to come to the bottom left pane over here and start the runtime. Next, we'll go ahead and start the dog mode logic application up here in the top left pane. And finally, we will go ahead into the UI and start the dog mode on. And what you will see over here is that this will set a state into the digital twin saying that the dog mode should go on. The event will be received by the application on the left-hand side, and we will see that it will report the change in status. I click here and we see that the dog mode has turned on. And I'm going to go ahead and now start the mock provider, which is going to start simulating the sensor data, such as raising the temperature of the cabin. Right, so now we have it running and we can see that both applications are receiving the events. The temperature is going up and you can see it's getting warm. So the application over here says the aircon needs to be set to on. It sends notifications also to the user. We can see that the aircon is blue over here. And when the temperature falls below a certain threshold, it also turns the aircon off. Now that we've seen the demo end-to-end, and before connecting you to one of the key principles of our project contribution around developer productivity and experience, let's pop open the hood and dig into the code a bit. I want to show you how the provider and the dog mode application interact with the runtime and the digital twin so that you get an overview of the application programming model. We'll start with the central piece, that's the runtime. That's over here in our repo in the SRC directory. Here we can see that there is the provider registry. We have the in-memory store for the vehicle digital twin and an event subsystem that's layered on top so that the applications are able to monitor the changes in the vehicle. The best way to explore this is by looking at the provider. So that's what I'm going to do next. I'm going to dig into the samples directory over here. We go into providers, mock provider, and I'm going to start by opening up the manifest YAML. So in the mock provider, we've taken a manifest-based approach to declare the capabilities, functions, and data that the mock provider exposes to the runtime and the applications. Here we see, for example, a capability called temperature that is exposing a data point such as the cabin temperature. And in another instance, we have a capability such as the air conditioning system with an aircon state as data and set air conditioning on or off as a function. Okay, so let's go ahead and look at the main entry point of the mock provider. We can see that it starts by connecting to the runtime's endpoint, and then we see further down it is loading the manifest that I showed you earlier, and it registers it with the runtime. We can see over here there's the register function that is receiving the manifest as an argument. I'm going to go ahead and open the register function. We see again the manifest over here, and this is the part where it announces all the capabilities, functions, and data found inside of the manifest to the runtime. Further down, we see that there is the publish data function. So once the manifest has been registered, the mock provider, the next thing it does is that it enters a loop, and at regular intervals, it's just publishing data into the digital twin, such as the cabin temperature, the aircon state, and the battery level. Now, one of the other parts that I showed you in the manifest was the functions. So we'll look at how those get handled in the mock provider. That's in a separate file over here called the functions handler. And here we can see the implementation of each of those functions. The implementations, of course, over here are very, very simple, but this is where we would expect an integration provider to connect to the actual hardware and forward the function to the actuators. Down here, we see that how all the functions that were declared inside of the manifest get mapped to their implementations above over here. Now that we've seen the provider side of things, let's move on to the application and see how the programming model can simplify, modernize, and enhance the developer productivity. I'm going to go into the applications folder this time and into the mock application for the dog mode scenario, and we're going to look at the main entry point just as we did with the provider. And you see that it connects to the runtime as the first step, then it starts listening to events. It registers the events that it is interested in, such as the dog mode status, the aircon state, battery level, cabin temperature, and then it enters into a loop where it waits for each event to arrive, and as they do, it matches them to the handlers on the right-hand side over here, and what these do is that they update the application state. So for example, when the cabin temperature is being reported, it takes the last reported temperature and the application holds it in its state. Once it has updated that, on each iteration of the loop, it runs the dog mode logic, which I'll dig into next. So that's the function over here that you can see is basically a bunch of simple if statements that are saying are certain conditions being met, and based on that taking certain actions. One of the examples of that being that the temperature exceeding a certain set threshold, which is 26 degrees as we see over here, it will, and the aircon isn't on, it's going to set the aircon to on. And this is going to call the function sending it to the runtime, and which then forwards it to the provider that's offering the air conditioning capability. Something we've been making sure is that the application programming model fully embraces the modern and robust development practices that application developers have come to expect, such as unit testing, debugging, quick inner developer loops, continuous integration and deployment. In light of that, the dog mode application that you see here is written entirely with unit testing in mind, such that all interactions with the runtime have been mocked out and tested without having the other components running. So I'm going to demo that next. I'm going to return to the demo you saw earlier and make sure that none of the runtime components are still running, because we want to make sure that the unit tests work completely in isolation. We're going to stop the application over here. We're going to stop the mock provider and the runtime. I will now return to the development environment, and what I want to show you is that what normally happens in our CI/CD pipeline in this repository, every time somebody does a commit, we do run the unit tests, and we can see over here that they run very fast, and they are running and passing in spite of the fact that the runtime and the mock provider were stopped. So this shows you that actually there's no interaction going on with those pieces. We will now go ahead and look at the tests. So I'm going to come over here and see one of the tests down here, which says that the aircon should be turned on when the temperature has exceeded the maximum threshold. And we're going to break this test by introducing a bug. I will go into the dog mode logic, and over here, when it should have exceeded the max temperature, instead of setting the aircon to on, I'm going to set it to keep it off by saying false over here. I'm going to save the file, and imagine that now I have done this commit. I push into the repository, and on the CI/CD, what I would normally see is that those tests should fail. And we can see that there's in fact 2 tests that are failing over here. We also see that the aircon should have been true. This is the expectation, and it happens to be false. So that is one of the tests failing over here. We see a line number where this the assertion has been offended. We can see that it was expecting some true over here, and obviously the data was false. Right, so now I know that I have a bug in my application. The next thing I'm just going to do is that in the development environment, I'm going to run this test in isolation. You can see that over here, I see there's still 1 test failing. I'm now going to go ahead and debug this. I'm going to go into this place where I introduced the bug. I'm going to set a breakpoint, come back to my unit test over here, and run it inside of the debugger, because I want to see what's really going wrong. I click debug, and now the debugger is launching. We see that it has exactly hit that breakpoint. I can examine my variables, such as the temperature being 27 degrees. We know that it's exceeding that threshold of 26 degrees. The aircon is not on right now. It's saying that it's false. And so it's entered this line and should have been set to true. And now I realize my mistake. I should have never set this to false. I can press play over here to resume this, and we will see that at the end the test has failed. Okay, I'm going to go in here and set this back to true. I will run the go back where the unit test is found, and I can run it once more. I can also try and debug it, but we know that we fixed the bug over there. Okay, so the test is passing over here. I'm happy with this. I can go back, and let's imagine that I have committed this change, reverted the mistake I had introduced earlier, and I do that, and our CI/CD pipeline is running those tests, and we can see that by fixing the bug, I've returned back to all tests passing again. So the last thing that I want to show you is that we have that breakpoint in the application that is still there, and I'm going to go ahead and run the other pieces, and we're going to debug against the actual system running. So for that, I'm going to return to the earlier demo screen. We are just going to go ahead and run the runtime over here. I'll also refresh the UI, and I will start the mock provider a little later. First, I'm going to make sure that the application itself is running inside of the debugger over here. So for that, you can see that inside this window over here, we have debugging set against all the parts of the system. I'm just going to say that I want to debug the sample application. I will now press play, and we will see that it will start receiving events. So one of the first events that we want to make sure that arrives over here is that through the UI, we're going to activate the dog mode. And I'm also going to start the mock provider over here. But I will just go and show you right now that in the debugger pane, we can see that at least the dog mode true event has arrived into the application. Right, so when we start the mock provider over here, it starts raising the temperature, and once the conditions are met, what we will see is that that exact breakpoint will hit at runtime. There we go. We see that just like in the unit test, the temperature over here is right now 27 degrees. It's gone above the max threshold of 26. The aircon happens to be at false state, and we will be setting it to true. So you can also see down here in the debugger that all the events where the temperature was being risen by the mock provider were arriving indeed. So I'll go ahead and press play over here. We'll see that the aircon has been set to on, and the next events keep trickling into the application. So there you have it. The debugging experience is pretty much identical, even if the system is running or not. Whether you're running unit tests, you can hit those breakpoints. Whether you're running it against a rail system, the same sort of experience is there. And one other thing that I want to reiterate is that everything you've seen from the application development experience remains the same, independent of which provider is being integrated. The programming elements such as functions, events, and the digital twin, they all stay the same between all provider implementations. This concludes our demo. If you have any questions about what you saw, let us know.
So I'd just like to say one word before we get this question later on online or here. There were no dogs harmed in making of this demo. Apart from that, lots of other tests were broken, but not the dog. Again, I have this live. I apologize for the online audience. If you want to see it in more slow motion, if there was any parts that we brushed over quickly or that was not clear, happy to show it to you live. Thank you, and I'll pass the floor to Filipe.
Thank you. So, slides, let me see. Yeah. So, before we close, we'd like to give you and let the audience with a couple of remarks. We want to drive and we would like to work with the community to drive this contribution, of course. So you saw Rust, you listened to me mention C++, but also the multiple layers that you see here from, for example, from the vehicle integration providers, definitely working with the community to bring those forward through a language that can help build the digital twin to provide that developer experience that you have seen. We also want, and again, there is a little bit of copy-paste there, but the secure, we want to make sure that the application programming model and the components are secure. As you saw from the demo, dynamic and extensible, so that application programming model can easily be replaced by community-implemented capabilities. Componentized, we would like to look into the single node and the multi-node that as we move forward through the software-defined vehicle, multiple architectures, and of course, become and be platform and cloud agnostic, developed in the cloud, but of course looking at our industry and delivered in the vehicle. Before I close out, I also would like to highlight the commitment from Microsoft to the community itself, and this was not possible with a lot of engineers, people, program managers that from our side is working and contributing to this first contribution. As I highlighted, some of them are here in the audience today. We can discuss during the break or during the social event, but I just wanted also to make and recognize the team that worked and contributed. And without this finishing, thank you for your attention and patience. Again, there is a little bit of a not very visible, but you can reach out to us through email, but of course we are Microsoft. You can also reach out to us directly through each one of our emails for future collaboration and work through the community. And once again, thank you for that.
Philip, Atif, thank you very much. Very interesting. So I would propose to have a small sticker with Eclipse, Chariott, dog mode protected. So yeah, let's turn it around, right? You have not sacrificed any kind of dogs, but that's a positive value, right? So thank you very much. Any questions from the audience in the room? I think there will be one volunteering to continue.
Yeah, so thank you for the interesting demo. I also like that it was written in Rust, even though I see that's not a strong technical argument, but I like that. But my question would be, to make sure, so the data you use, like temperature in the car, battery state, air condition, so to make sure it can run in more than one car, did you base it on something like the VSS standard or the Android VHEL, or is the idea to develop a new data model for this?
Yeah, that's a very good question. So the way we see the collaboration with the communities, of course, can become a provider. So we are looking, of course, at DTDL, for example, for the in-vehicle digital twin, but we don't necessarily mean that DTDL becomes the standard at all. We want to work with the community. Any single standard for the specification of the vehicle signals is welcome to work and bring it to the implementation. So again, working with the community, no specific direction there.
So, a question from the online chat. How will that be different if one uses C++ to develop modules based on your SDK? There is a lot of grammar sugar in Rust.
So the question, if I understand right, is that how would it look like in C++?
Yeah, exactly. That's my understanding of the question.
Okay. So I think you saw that it was written in multiple languages. We had one done in C#, one done in Python, and we also did it in the dog mode logic application was written in Rust. So those bindings at the moment, the one we experimented the most with was Rust. We've not looked at the C++ one yet at the moment. This is something that we're exploring. Part of the reasons we chose Rust for this was simply an exploration of seeing how, as we were saying, that it's about the application programming model, about the developer experience, how can we, increase the inner loop, bring those unit testing things, the modern and robust development practices that, generally developers expect. And so that was just what we were experimenting with in this first incarnation of the application programming model. In terms of C++, that's something that we would love to explore going further. But in this case, we didn't do that right now.
Okay, I have two short questions from the online side. Are any Visual Studio extensions being planned for this?
No Visual Studio extensions. I mean, over here, what you see is basically the thing that you saw over here is described in a dev container, which is the configuration file is part of the repo. So what it allows you to do is get the entire same set of versions of the tools, the compiler, the entire tool chain that you saw with whether that be Rust or C# or Python, gets installed on every developer's desktop. And not only that, that when you go onto the cloud, it's the same experience you get. So we were looking at that part with this application programming model.
Okay.
Yeah, but just one.
Go ahead.
As a program manager, I welcome for us to actually, in the community, build those extensions, because I think we want to make our life easier as we work through the software-defined vehicle.
Yeah, I think I'd like to add to that is that we're not here to say it's a product, right, that we're coming up with over here. So obviously, if there's community people want to do contributions, that's great.
Yeah. Another short question online, and I will try to maybe have one more on-site question. Are the metadata and the application exposed via RESTful API?
Currently, they're not exposed as a RESTful API. That's something we want to work on with the community to figure out what is the best way to expose it within the vehicle and the inter-component communication. There's obviously a lot of different choices available. And maybe that some components communicate over a different protocol than other components, depending on the individual needs. But the goal is to standardize, and so that different implementations of different components can exist. Again, kind of going back to the Eclipse SDV project, that there is no single SDV stack. And we encourage the contributions of the different components.
Okay. Any questions from the room? I have the mic, just raise the hand. One. No? Okay, last, in the last second.
Hi there. It's about security. How do you ensure that the data you are subscribing is secured? So how is the manifest or how is the application authorized?
So one of the things that's not part of this first contribution is a larger architectural model. which includes both multiple layers, including down integration with the operating system, trusted layers, and so on and so forth. We hope to be working with the community to sharpen that and start addressing these things. What we were focused on with this first contribution is really making sure that the application programming model is something that is dynamic, extensible, and flexible, and allows that inner loop of development to be as agile with high code velocity as possible. So that's just this first contribution. We do have a bunch of other stuff in the pipeline.
Yeah, okay. One final question, a quick one. Yeah, can you just hand over the microphone?
So do you use any particular technology for deployment into the vehicle? I mean, I believe you did not use it here, but what's your plan?
So the larger plan is, as far as developing in the cloud and stuff, some of the stuff that we're working on is ARM64 within the various clouds and developing those. A lot depends on which component you're talking about. These are all containerized. So the concept is that since the digital twin and the components below that are the vehicle integration layers, your applications can be developed in the cloud and then delivered to the vehicles as containers. And therefore they're completely portable. In the ideal state, if you have a standardized digital twin, kind of like what we were just talking about with providers for VSSO or something, then that container would go ahead and work on all the vehicles in the entire fleet. So that's the idea.
Great, thank you very much. It was a pleasure to listen.